Okay, this is the what? Find the solution using a northwest corner method. Sometimes they will ask you that initial PGM solution, feasible solution also. That's also be correct. But for this solution, you have to make the allocation properly based on northwest corner method. Okay. In this method, here also must and should you have to do whether the given solution is a balanced or unbalanced. Okay, 14 plus 16. How much? 30. 30 plus 5, 35. With respect to the supply. With respect to the demand, 10, 10 plus 10, 20, 20 plus 15, 35. Then given numerical is balanced. Is it required to add any dummy column or dummy row? Not at all. Be required. Because given transportation numerical itself is a balanced numerical. Keep this in mind. First and foremost thing. Then once you identified this, then you can go for the solution. Always, whichever method, first you identify whether it is a balanced or unbalanced. Then you can decide for the adding of dummy row, dummy column. Corresponds to that of the what you need to match. Okay, then note down the solution with respect to that. What you have to do? The total number of supply constraints is 3. The total number of demand constraints are 4. Okay, these are the supply constraints 3, demand constraints 4. Okay, M and N values. But now it is not required. I am following that is at the last. Because whether the solution which it is to be available for the evaluation purpose point of view, it is non-generate or the generate solution. That's the reason we want that value. Okay, once you did this, okay, then you have to make the north corner method. Okay, in this method, okay, first you have to go for the value which to be get provided with respect to that of the individual value which are to be represented with respect to that of the supply and demand. Okay, supply is 14. Okay, then demand is 6. Okay, then I can meet this 14. Min of 14, 16. No, not 14, 6. It is the 6, which is assigned for S1 and D1. S1 and D1. Okay, so that I have to take at 6 rupees, 6 quantities. Okay, you don't think on here for the minimum cost of transportation. Because minimum cost of transportation you are considering in VAM method only, not here. 6 is allocated, the 6 will become 0. Okay, then 14 minus 6 is what? 8. Okay, then this is the updated table. Okay, particular row or column is 0. Okay, you have to neglect that the next evaluation. Okay, second step. Okay, you have to go for now north to here, then north to west, like that. Okay, what is the min of value with respect to that of value which are to be assigned? Okay, here is 10, here is 8. Can I supply? Possible. 8 is get supplied to this 10. 8 minus 8 is 0. Okay, then this is 10. What is the cost? 4 rupees. Okay, for this 4, how many quantities I am allocate? I am going to allocate the 8 quantities. Okay, remaining is how much? 2. Then this will become 0. Once it becomes 0, you delete that, which is not required for the further steps, for the consideration point of view. Okay, is this clear? Okay, next, always the vertical and horizontal. D1, S1, D2, S2, then D3, S4. Okay, like that, the method what you need to be required to follow until and unless all the supply and demand make it at 0. That method you can follow. Next, with respect to D2, S2. Okay, D2 and S2. Okay, if you considered. What happens with respect to that? D2 and S2, here is 16, here is 2. 16, 2. Okay, for this reason, okay, I'm going to allocate with respect to the 9, 2 quantities. Here it is 2, I'm going to allocate with respect to the 9. Remaining how much? 14. Remaining how much? It is 14. So that if this demand becomes 0, then you have to delete this D2 S2. Now this complete column is deleted. Now this also become 0. Okay, how many you are allocated? 2 quantities you allocated. Then 16 minus 2 is how much? 14. So that 16 minus 2 is 14. Okay, next S to the D3. S to D3. S2 is 14, D3 is 15. Okay, S2 is 14, D3 is 15. Okay, at 2 rupees, I can allocate 14. Then how many is left? 1 will be left. Here, at 2 rupees, 14 I am going to allocate. 14 minus 14 is 0. 15 minus 14 is 1, which will become 1. Okay, now you are going to delete this complete row itself. Then how many quantities are left? 5 with respect to that of 2. Okay, then you can proceed for the same S3 and D3. S3, D3. Okay, which is the minimum value? 1. Okay, that is the 1. At a rupees of how much? 6. Okay, 1 I am going to allocate here. How many is left? 5 minus 1. It is 4. 5 minus 1 is 4. Then it will become 0. 6 rupees, 1 quantity. Okay, only 1 it is left out. Okay, this will be allocated to this 2. Okay, so that min of this is 4. Then at 2 rupees, we are going to allocate the 4 quantities. All the supply and all the demands are become 0. All the supply and demands are become 0. Once it becomes 0, we will get the feasible solution. Is this clear? Raise your hand if you are listening. Okay, this is very simple method. It is northwest corner method. Very easiest. Okay, you people are not practicing. Practice numerical. Then only will get the proper solution. If not, you won't. Okay, this is what the method is need to adopt. Okay, once you did this, you know already m plus n minus 1. Okay, here 4 plus 3 minus 1. How much it is? 6. Okay, whether you are having the 6 allocation or not, you have to identify. 1, 2, 3, 4, 5, and 6. 6 allocations are there. If the 6 allocations are exist, then only it is not non-degenerate solution. Okay, that is you have to remember. Non-degenerate solution. Once you got the non-degenerate solution, make the evaluation of the total cost. If not, make that degenerate, then you have to make the evaluation of the total cost. Okay, this is the method what you need to follow with respect to numerical solution point of view. Okay, one have tried this, but that is also be incomplete in internal. Okay, but you have to practice, then only you can complete the solution. If not, you can't. Okay, once you did this allocation, then you have to rewrite the feasible solution table. Okay, 6 rupees, 6 quantities, 4 rupees, 8 quantities, 9 rupees, 2 quantities, 2 rupees, 14, 6 rupees, 1, then 2 rupees, 4. Okay, then you have to multiply with respect to that. 6 into 6, 4 into 8, 9 into 2, 2 into 14, then 6 into 1, 2 into 4. The total cost is how much? 128 rupees. Okay, that is making here na 3 plus 4 minus 1 equal to 6. then it is solution is non-degenerate. Once you did this non-degenerate solution, then you are getting the optimal solution. If not, that is not the optimal solution for the evaluation point of view.